In this tutorial, we'll review the procedures to perform a hypothesis test for the mean of paired differences in SPSS. This is for when you have measured people, for instance, at 2 points in time. For example, a pre-test, then some sort of intervention, and then a post-test afterwards. And you want to look at the changes in each person's scores over time to see if those changes are significantly different from zero. To do this, I'm using a hypothetical data set that I've created with pre-test scores and post-test scores that go from 1 to 10. I come up to Analyze and down to Compare Means and down to Paired Samples t-test because we are pairing the scores on these two variables. Although it's customary to enter the data pre-test first and post-test second, paired sample t-tests use subtraction, and so it's common here to put the post-test score first because it will then subtract the pre-test, and a positive score will show that there was an improvement over time. Do this by clicking on Post-test and selecting, and it goes in here, and then selecting pre-test and putting it in right there. So I have post-test as variable 1 and pre-test as variable 2, and click OK. This first part is a syntax statement that's just a written record of what I've done. This says that this is where the results for the t-test begin. The t-test is the inferential statistic that's used for this paired sample comparison. This is the data set. This gives the means of each group. The pre-test mean is 3, the post-test mean is 4.58. There's 24 people. They have scores on both of them. There are the standard deviations and standard errors for both. The scores are highly correlated. This one shows that there's a correlation of 0.433 between the pre-test and the post-test. So it's not totally changed. There is carryover, and that is a statistically significant correlation with less than 0.05. It's a significance level or probability level of 0.035. The one we're interested in, though, is this last one, the paired samples test, which looks at the difference between the post-test and subtracts the pre-test. There's a mean improvement of 1.583 because it's a positive number because I did the post-test score first, with a standard deviation of 2.02, the standard error. And then we're going to look at this one down here. The t statistic is 3.840 with 23 degrees of freedom, which has to do with the 24 cases that are in it. And it's this last number right here that we're interested in. The sig two-tailed is the probability value for the hypothesis test. In this case, it's 0.001, which is less than the standard cutoff of 0.05 for a statistically significant result, meaning that in my hypothetical data, we showed a statistically significant improvement from time 1 to time 2. And that's the way that you do a hypothesis test for the mean of paired samples in SPSS.